Pluto, a distant and puzzling celestial frame, was as soon as regarded as a wonderful and legitimate planet inside our sun machine. It turned into considered a member of the planetary family until current provocative statements by means of main astrophysicists Neil deGrasse Tyson and Michio Kaku thrust Pluto back into the highlight. These renowned experts have made a startling declare. Pluto can be on a capacity collision course with Neptune. But how is such an occasion viable? What may want to the effects of one of these gigantic occasion be? Are we witnessing a captivating cosmic anomaly? Or is there more to this approaching celestial occurrence than meets the attention? Join us as we delve into the possible repercussions of a Pluto-Neptune collision. Pluto, as soon as classified as a planet but relegated to the reputation of a dwarf planet, keeps to seize the curiosity and interest of astronomers and researchers in the substantial expanse of the universe. In line with research with the aid of leading area scientists, Pluto's orbit is precariously near Neptune's. Astrophysicists, which includes Tyson and Kaku, have raised concerns about the potential dangers posed by way of a collision between these two celestial bodies that could, in flip, pose a sizable risk to Earth. However, how may want to any such catastrophic occasion unfold? Pluto's orbit across the Sun is in contrast to that of another planet within the Sun machine. It takes a brilliant 248 years to finish an unmarried orbit. This means that seeing that its discovery in 1930, Pluto has no longer even finished one full orbit, but the intrigue does no longer stop there. Pluto's orbit is marked via an unusual form, significantly exclusive from the nearly round orbits of the principal planets. What makes Pluto's course so much extra unpredictable is its 17 degrees inclination relative to the ecliptic plane, which makes its orbit considerably extra erratic compared to the other planets. This oddity provides in addition complexity to Pluto's orbital conduct. Possibly one of the maximum charming aspects of Pluto's orbit is its interaction with Neptune. For approximately 2 decades in each orbit, Pluto without a doubt comes towards the solar than Neptune, which contradicts our expectancies based totally on their positions within the solar device. This increases the obvious question: why hasn't Pluto collided with Neptune already? The answer lies within the gravitational influences exerted with the aid of other planets in the gadget. The look at of Pluto's orbit started out quickly after its discovery. To begin with, astronomers have been puzzled by means of its erratic direction. Not like different planets, whose orbits lie close to the ecliptic plane, Pluto's route stood out because of its steep inclination and unusual form. The mystery surrounding Pluto's orbital traits can be defined through an idea referred to as the three-body trouble in celestial mechanics, which seeks to apprehend the motion and interaction of 3 gadgets, Pluto, Neptune, and the Sun, under their mutual gravitational impacts. It's akin to predicting their destiny positions based totally on their current states and the way they have interaction with one another. For Pluto, this problem suggests that the orbits of Pluto, Neptune, and the Sun work together in an intricate way. Phrases like asymmetric libration, scope libration, and VSK wobbling are crucial to this puzzle. Astrophysicists accept as true with that the purpose all planets keep their orbits is due to a type of libration, which in the case of Pluto and Neptune method that after Pluto crosses Neptune's orbit, their positions are separated with the aid of about 90 degrees. This distance performs a critical role in stopping their orbits from overlapping and inflicting a collision. Furthermore, libration refers to the vertical motion of a celestial body inside its orbit. For Pluto, which means whilst it comes closest to Neptune or another huge planet, it is located a ways above the plane in their orbit, adding every other layer of protection from possible collisions. A further important element in this equation is the VSK wobbling, named after the researchers who first studied how items pass in space. The VSK wobbling refers to the way gravitational forces exerted by using Pluto, Neptune, and the Sun affect each other's movement. This interaction of gravitational forces allows maintain Pluto's orbit even if it takes an unconventional path near the Sun. The VSK wobbling is critical in keeping Pluto's orbit stable for enormously long durations, even when the apparent randomness of the device would possibly advocate otherwise. This phenomenon guarantees that no matter the seemingly erratic nature of Pluto's orbit, sure forces and patterns help hold the entirety in test. These gravitational forces and phenomena play a crucial role in ensuring Pluto's orbit stays strong, consequently preventing capacity collisions with Neptune or some other celestial frame. The three-body trouble is important for know-how gadgets in space interact with every other. It sheds light on Pluto's movement and enables astronomers recognize the gravitational outcomes on different celestial bodies, which include distant stars and planets. Mathematical simulations within the past 1980s found out that no matter the unpredictable capabilities of Pluto's orbit, its course stays stable with simplest minor deviations in its initial situations. Those features of Pluto's orbit have remained constant over lengthy durations, permitting astronomers to refine their information. Later laptop models have also helped us understand how the bigger planets, which include Neptune, Jupiter, and Saturn, affect Pluto's orbit. Neptune shares a completely unique coordinating with Pluto, in which for every orbits Pluto completes around the solar, Neptune completes 3. This resonance facilitates stabilize Pluto's orbit. However, Neptune's influence is not the handiest element. Jupiter's gravity additionally plays an essential position in keeping Pluto's solid orbit, as does Saturn, whose gravitational pull extends at some stage in the outer reaches of the Sun system. Studies endorse that Jupiter's big gravity is enough to make certain Pluto stays on a steady trajectory for a really lengthy duration, likely even billions of years. Together, Neptune, Jupiter, and Saturn may be operating in tandem to maintain Pluto properly on path, heading off any disruptions in its orbit. These irregularities inside the planetary system play an important function in maintaining balance within the Sun system. Without those forces, our community and area might be some distance extra unstable, with objects like Pluto probably colliding with others or being ejected from their orbits, causing chaos amongst other celestial bodies. Information Pluto's orbit is mainly essential, in particular as there's speculation about a potential collision with Neptune in the distant future. The problematic dating between Pluto's orbital pattern and Neptune's allows us gain a deeper know-how of how neighboring planetary structures perform and interact. The case of Pluto demonstrates how even in reputedly chaotic orbits, equilibrium can be completed via the complicated interplay of gravitational forces and orbital mechanics. It additionally highlights the significance of ongoing statement and evaluation to control our place within the universe. Reading the depths of area regularly forces us to confront the ordinary and every so often unpredictable nature of celestial bodies, and Pluto's orbit serves as an excellent instance of this unpredictability. The potential for orbital resonance, the vital relationship between Pluto's and Neptune's orbits, is the essential factor of this dynamic. The 2:3 orbital resonance ratio among Pluto and Neptune guarantees that in spite of crossing paths, they by no means collide. This resonance is a crucial piece of the celestial puzzle, stopping any catastrophic interactions. Resonance, wherein Pluto's orbit is in a 2:3 ratio with Neptune's, is a key precept in celestial mechanics. For every 2 orbits Pluto completes across the solar, Neptune completes 3. This gravitational resonance allows stabilize their orbits, ensuring that even though their paths pass, they do now not collide. This sensitive balance is a high example of ways apparently chaotic systems in space can self-regulate through subtle gravitational forces. Similarly to Neptune's have an impact on other massive planets like Jupiter, Saturn, and even Uranus play a function in maintaining the stability inside the Sun gadget. Jupiter's gigantic gravitational pull acts as a safeguard for smaller bodies like Pluto through influencing their orbits and preventing them from being thrown off route. Some scientists speculate that Jupiter's gravity can also have even prevented Pluto from being ejected from the solar machine absolutely. Those findings underscore the significance of knowledge the gravitational forces at work in our solar system. Whilst Pluto's orbit stays strong for now, there's continually the capability for modifications inside the future. As astrophysicists like deGrasse Tyson keep to discover the universe, they offer us with a deeper understanding of the sensitive balance that governs the movements of celestial bodies. The possibility of a Pluto-Neptune collision serves as a reminder of the continuously evolving and complex nature of the universe, illustrating the need for continuous exploration and take a look at the forces that form our solar gadget. This ongoing study of Pluto's orbit and its interactions with other celestial bodies is not only vital for information our solar gadget, but additionally for exploring the wider universe. As scientists like deGrasse Tyson preserve to take a look at the dynamics of area, they spotlight the evolving nature of celestial mechanics and the complexities involved in predicting the future moves of planets and other items. The possibility of a Pluto-Neptune collision even as unlikely, is a reminder that the universe is filled with uncertainties, or even the most stable systems can go through profound adjustments over time. Furthermore, Pluto's case exemplifies the intricacies of orbital resonance, wherein the movements of celestial bodies are intricately connected. The 2-3 orbital resonance among Pluto and Neptune ensures that notwithstanding the crossing in their paths, a collision is avoided. This resonance is a right-away result of the gravitational interactions among the two bodies, creating a sensitive stability that has saved Pluto's orbit strong for billions of years. It is a high instance of ways gravitational forces, even in reputedly chaotic structures, can produce strong and predictable consequences over lengthy intervals. The importance of this resonance can't be overstated. It serves as a fundamental principle in celestial mechanics, demonstrating how even the maximum complex and irregular orbital patterns can keep concord through subtle gravitational affects. This know-how of resonance also extends to the wider dynamics of the Sun gadget, wherein the interplay between planets, dwarf planets, and different items is crucial to preserving the stability of the gadget. Jupiter, especially, plays a pivotal position in the common stability of the solar device. Its large gravitational pull acts as a protector of smaller items like Pluto, assisting to save them from being flung out of orbit or into catastrophic collisions with other bodies. The gravitational influence of Jupiter extends nicely beyond Pluto, impacting the orbits of asteroids, comets, and different small bodies in the outer Sun gadget. This in addition highlights the interconnectedness of the numerous items in our Sun machine and the way their gravitational forces paintings collectively to maintain order and balance. In reality, a few researchers endorse that Jupiter's gravitational effect may additionally have played a function in ensuring that Pluto remained in its modern orbit rather than being ejected from the solar system totally. Jupiter's gravity may additionally have helped capture Pluto, stopping it from being sent off into interstellar area. This scenario underscores the importance of expertise, the role of each planet in shaping the overall structure and dynamics of the solar device. The study of Pluto's orbit and its interactions with different planets additionally highlights the dynamic nature of space. Even as mathematical simulations and laptop models provide treasured insights into the conduct of celestial bodies, additionally they monitor the inherent uncertainties in predicting the lengthy-term moves of these items. Small modifications in initial situations or minor deviations in gravitational forces can cause vastly one-of-a-kind consequences through the years. This uncertainty is a reminder of the complexity and unpredictability of space, and the need for continuous commentary and analysis to refine our information of the forces that govern the universe. Inside the broader context of area exploration, Pluto's orbit provides precious training about the intricate balance of forces that shape the conduct of celestial bodies. The truth that Pluto's orbit has remained strong for billions of years, in spite of its erratic and unusual characteristics, speaks to the electricity of gravitational forces and the self-regulating nature of orbital mechanics. It also underscores the importance of ongoing studies and the need to constantly refine our models of the way planets and different gadgets circulate via area.